This is video 3 for fractions, and we are adding and subtracting. So on this one, I've given you an example. If we're adding and subtracting what we call like fractions, you will see that they already have the same denominator, and that is something that has to be. The only way we can add them is if they have the same denominator, because we have to add them in the same amount of portions, right, that are there. And so on this one, we have 2/9 plus 5/9, which would be 7/9. If I were subtracting some fractions, I would do the same thing if they had the same denominators, right? So notice on 4/9 minus 2/9, I get 2/9. I just subtract 4 minus 2, and we keep the denominator the same. The only time the denominator will change is if we can simplify the fraction after we added it or subtracted it if they start out the same. So don't add your denominators. That's the main thing, or subtract your denominators. Excuse me, I'm about to cough there. Fractions having different denominators are called unlike fractions, and so we can't just add them when they look like this. We have to rewrite them so that we have the same denominator. So for 2/3 and 3/4, 3 and 4 don't have anything in common. That means we can just multiply them to get that same denominator. So I'm taking 2/3 times 4/4, and that gives me 8/12, and 3/4. Remember, these are equivalent fractions, and that gives me 9/12. And then I can add them. So I add the 8 and the 9, I write it over 12, which gives me 17/12, which is also 1 5/12 as a mixed number. You know, improper fractions are okay, but mixed numbers are helpful. If we're talking about things like measurement or something, then that's where that comes into play. All right. All right, I experienced one of those glitchy things that seems to happen with my app. Okay, so here's a calculator method to find your least common denominator, because when you are working with fractions, sometimes you need to know how to find your common denominator. And least common denominator is what we're shooting for. So the easiest way to do that is take your larger denominator and write some multiples of it until you find the one that they all divide into, right? You can test it as you go. So we're going to go with 15. So 2 times 15 is 30. Well, 4 doesn't go into 30. 10 does, and 15 does, so we're not there yet. 3 times 15 is 45. And so 4 and 10 won't divide into 45 and give me a whole number, right? And so one more, 60. And so when you check this, you'll see that 4 divides into 60, 10 divides into 60, and so of course just 15. And so our LCD is going to be 60. Okay, let's look at the next one. So we have 3, 7, and 12. Now, 3 goes into 12. So we really only have to check the 7, because no matter what the number is, 3 is going in there, right? 3 and 12. So we start with 12. 2 times 12 is 24. Well, 7 won't divide into 24. 3 times 12 is 36. And 7 doesn't go into 36. 4 times 12. Remember, this is 1, 2, 3. 4 times 12 is 48. The 7 doesn't work on that one. 5 times 12 is 60. Still not going to work. 6 times 12 is 72. And we finally find it. We have to go all the way to 7. Well, that would make sense. 7 times 12 is 84. And so our LCD will be 84. Now, that took a few tries to get there, but I just wanted you to see that even if it does, it's pretty easy, because you're just multiplying your largest number times 2, 3, 4, 5, and so on. All right. So adding and subtracting fractions. Here's the deal. You can just use your calculators, but sometimes I will ask you for the LCD, right? What is my LCD? So for these two, you can see that 8 goes into 16. That's always something you want to check. And since it does, my LCD is going to be 16. And that means I can just multiply this number by 2 to get that same denominator. So I'm going to add 7/16 plus 6/16. Right, that gives me this. And that would be 13/16. So we're finished with that one. Now let's look at the next one. So 1/2, 1/4, 1/2 plus 1/4 minus 1/8. 2 and 4 go into 8. So my LCD is going to be 8. Now I don't have to rewrite the 1/8. It's going to stay. But I do have to rewrite the 1/2. So it needs a denominator of 8. So I'm going to multiply it by 4 over 4. 1/4 needs a denominator of 8. We're multiplying that by 2. And the 1/8 gets to stay. So we got 4 over 8 plus 2 over 8 minus 1/8. So then we just go in the numerator, and you know order of operations would apply here, but we're just adding and subtracting, so it's left to right. 4 plus 2 is 6 minus 1. So that is 5/8. And then on the last one, I mean your calculator would do this, but let's just do this with improper fractions. So I'm going to have 16/3 minus 12/5. So I think you can see on this one, since 3 and 5 are actually prime numbers, then the only thing that we would need to multiply by are the 3 times the 5 or the 5 times the 3. So we're going to multiply by 5 over 5 and 3 over 3. Here's what we end up with. So 16 times 5 is 80. 12 times 3 is 36. And then we take 80 minus 36, which is 44/15. Or as a mixed number, 15 is going to go in that 2 times with 14 left over. So 2 and 14/15 in mixed number form. All right. Here's a application problem. So this is about plumbing. If a piece of 3/8 inch inside diameter copper tubing measures 9/16 of an inch, if a 3/8 inch, that's our inside diameter copper tubing, measures 9 inches on the outside. So this is the inside diameter and the outside diameter, which is a common way to write about this type of thing in your book. It says, what is the wall thickness? Now, a lot of times students think they just subtract. Oh, I just take the outer diameter and I subtract the inner diameter, but it's a little trickier than that. And so, let me see, I'm going to just try to draw a couple of circles. They're not going to look that great, but we'll pretend. How's that? So here's my inside diameter of 3/8 of an inch. And then my outside diameter is 9/16 of an inch, right? From here to here. Now think about all the way across this thing. To get the 9/16, I have to add this piece and this piece. So there are 2 of them. And that's why lots of times students will miss this problem. So that means I have to take my inside diameter and subtract it, but it's going to be times 2 to get my correct outside diameter. So I know that seems, well, hold on. I'm going to do this first. We're just going to subtract, and then we'll talk about how to get those x's. I'm saying this kind of wonky, so we got to talk about this. So first I'm just going to subtract, right, to find the difference. We do have to do that first. I'm getting ahead of myself is what's happening. So I'm going to multiply that by 2 over 2. So the first time when I was teaching this to my students, they wanted to kind of argue about this, but I understand that because it seems a little bit confusing, right? Very confusing. So here's what's left over, 3/16 of an inch, but that's 2 parts equal that 3/16. I should have done the subtraction before I tried to explain that. And so what happens is we have to divide that by 2. Right, let's divide that by 2, or 3/16 times 1/2 would be the same thing. So each of those walls of our pipe, our tubing, not pipe, well, it's kind of the same thing. Our tubing is 3/32. So if you just subtracted and stopped there, then you would have the total width of the tubing on the 2 parts, but you wouldn't have just one of them. You'll have some more problems like this, so you'll be faced with this again. And so hopefully that'll be helpful to practice it more than once. All right, here's our next one. How long a bolt is needed to go through a piece of tubing that is 5/8 of an inch, a washer 1/16, and a nut that's 1/4. And there's nothing tricky on this one. You're just going to add them up, okay? So I am going to actually pause this for a minute and write this out because we're getting low on time and I only have 2 questions left. So one moment. All right, so I've got them written out. Now we need to write them each with a denominator of 16. So on this one, we're going to multiply it by 2 over 2. So that will be 10/16. We're going to multiply this by 4 over 4. So that will be 4/16. And then we simply add them together, right? So 1 plus 10 is 11 plus 4, and that's 15/16 of an inch. All right, so we got almost to 1 inch with that total. And then here's our last problem. A cabinet 30 inches high must have a 4.5 inch base and a 1 3/4 inch top. How much space is left for the drawers? Okay, so basically you can see that we have a total of 30. We have to take out the top piece and this bottom piece, and that leaves us the drawers, so it is subtraction. We're going to take 30 minus, now 4.5 is 9/2 of an inch. And then 1 3/4 is 7/4 of an inch. And you know, on this one you could just use your calculator and subtract it that way. But if I write these all over 4, then I'm going to have 120 over 4 because I'm multiplying times 4. I'm going to multiply this one by 2. So that's going to be 18/4 minus 7/4. And then I'm going to take 120 minus 18 minus 7. And that leaves me 95/4. Or that would be 23 3/4 inches. So with your calculators and the mixed numbers or as improper fractions, either way is okay. But that is the end of the fraction lesson. Bye everyone.